Good morning. We have seen some of the topics related to Model 5, and in the last video, we discussed about task communication, and we were discussing the mechanism used for inter-process communication. And in that, there are three mechanisms, out of which we have finished in the previous video one mechanism known as shared memory. So in today's video, we will go ahead and see another IPC, that is inter-process communication mechanism, known as message pass. So let us see what is message passing. Message passing is considered to be one of the forms of information exchange mechanism in inter-process communication, and the difference between the shared memory and message passing basically is, in shared memory we can pass on or share a lot of data. There is no data restriction as such in shared memory mechanism, whereas in message passing we can only pass on a limited amount of data. So there is a limitation on the data that can be passed using message passing mechanism. Message passing is considered to be relatively fast and is free of synchronization overheads. So the advantage of message passing, we can say that compared to shared memory mechanism, it is fast and the overheads are less. Message passing mechanism can be further classified into three different modes known as message queue, mailbox, and signaling. So we'll see one by one each mechanism. Let us go ahead and see message queuing. You have gone ahead and seen this topic of message queue and mailbox. You are familiar with this message queue and mailbox mechanism through the subject of operating system. But let us once again go through the same topic, message queue. Message queue is considered to be a process. Suppose if we have a process which wants to talk to or pass the information to another process, then the process which wants to pass the information posts the message in FIO, that is first in first out queue. This first in first out queue is also known as message queue, and message queue is considered as temporary memory storage or temporary storage memory that is system defined. So here the process posts the message. So here the message passing occurs through message queue. And how does the message passing occurs? The message passing occurs through a command or methods known as send and receive methods. Okay. So send and receive methods, are kernel dependent. That means the implementation of this message queuing becomes OS kernel dependent. So you can see a figure wherein process 1 wants to communicate or pass the message to process 2. So if the process 1 wants to pass a message, so process 1 will use the command send message, wherein the destination address to the process which it wants to send the message is mentioned in the send command. So you can see that here the process 1 wants to send the message to process 2, so obviously process 2 becomes the destination process. So process 1 sends the message, but the message goes into the message queue or posted into the message queue. Here kernel will keep on checking the posts that are there in the message queue one at a time. So it will examine whether the message is from which process and what is the destination process. So based on the send command, it will understand that the destination process is process 2, and then the kernel will post the message from the message queue to the process 2 when process 2 makes a receive call. Okay, so here the posting of message occurs from the message queue to the process 2 when the process 2 makes a receive call. So this is about the message queue. Next, second mechanism in message passing is using mailbox. So this is mailbox is an alternate way similar to message queue, but the only difference between the message queue and mailbox is that message queue can be two-way communication or two-way messaging, whereas mailbox is usually used for one-way messaging. Now here we can exchange a single message, but the exchange can occur between one single process and multiple between if one process wants to send across the message, it will post the message into mailbox, and through mailbox it can go to multiple number of tasks or processes. Or it mailbox can also be used in communication between ISR and the task, that is interrupt service routine, and the task as well. Here even mailbox is kernel dependent, implementation of mailbox is kernel dependent. So let us see the example of mailbox with a figure. So you can see that one of the task here, we consider task as task 1 wants to send the message to the other task. So the task which wants to send the message will be the one which will create the mailbox. So in this case, task 1 is the task which will create the mailbox, and the from the mailbox the receivers are multiple receivers. So we can say that we have already seen that the mailbox can be used for communication between, or to send the messages to multiple processes. So here you can see the in the example the message has been received by task 2, 3 and 4. So the thread or the task which creates the mailbox is known as mailbox server, and the task or the thread which is wanting to receive this message are known as mailbox clients. So these mailbox clients has to subscribe to the mailbox saying that we want to receive the messages. So in the example or in the given figure, task 1 is a mailbox server, whereas task 2, 3 and 4 are mailbox clients. So here mailbox server will post the message and notify the client mailbox, and the client mailbox upon receiving the notification will read the message. So this is what happens in mailbox, implementation of mailbox. All this sending, message receiving, message sending, message notifying, all these operations are done by OS kernel using APIs. Okay. The third mechanism is signaling. So the signaling mechanism used in message passing. Here it is a primitive way for communication between the process or the task. Signals are considered to be a synchronous notification. When one of the processes is firing a signal, this firing of the signal indicates that there is an occurrence of some scenario which the other process was awaiting. Now signals cannot be queued, and it does not carry any kind of information or data, and whenever the signal occurs, generally the signals that occur are handled by a signal handler that is associated with a particular signal. So these are the three methods of message passing. So generally message passing mechanism is used as a separate question, wherein you have to explain all the three mechanisms, that is message queue, mailbox and signaling mechanism. Thank you.